Okay, imagine southern Iraq centuries ago. We're talking about a landscape absolutely covered in massive ancient earthworks. Linear ridges, miles and miles of them, canals woven through. It's a system built by human hands on a scale that's, frankly, hard to even picture today. For a long time, the traditional story linked these structures directly to, well, brutal slave labor, specifically tied to one of the most significant revolts in history, the Zanj Rebellion in the 9th century AD. The thinking was this massive uprising was a breaking point, leading directly to the decline and eventual abandonment of these incredibly vast agricultural fields. But what if new evidence, the kind you can only get from really digging in, sometimes literally challenges that long-held belief?
That's precisely what this deep dive is all about. We're looking at a fascinating piece of new research, just published in the journal Antiquity. This team drew on everything from satellite imagery, both incredibly detailed recent shots and older ones, like the incredible declassified imagery from early spy satellites, the 1960s corona photos, to the cutting-edge science of dating ancient sediments, using techniques like optically stimulated luminescence.
All right, we've got our stack of sources here pulling directly from the research article itself. Our mission is to really unpack these findings, see what they tell us about this incredible modified landscape, the people who built and used it, and whether the historical narrative we thought we knew actually holds up under the light of this new evidence.
Yeah.
So, okay, let's unpack this landscape. Where exactly are we, and what do these structures physically look like?
We're in the Shaṭṭ al-ʿArab floodplain in southern Iraq, specifically in the Basra Governorate. It's a vast area.
It really is.
The research highlights a network covering more than 800 square kilometers, and the physical features are striking. A huge network of linear ridges or earthworks and associated canals. Using satellite imagery, recent and those older corona photos, they've identified over 7,000 of these ridges.
It's over 7,000. Just wrap your head around that number for a second. And they're not small.
No, not at all. The report mentions they're typically 400 to 1,200 meters long, 20 to 50 meters wide, and can reach up to 2 meters high. They're laid out in these parallel groups, almost like blocks, separated by flat land, all arranged around these relict canals.
Wow. If you were to lay every single one of those identified ridges end to end, what would that even be?
You'd have something like 3,000 kilometers of these earthworks.
3,000 kilometers of raised earth built by hand. The sheer scale of this system isn't just impressive, it screens human labor on a grand scale.
Absolutely. Building something like this required either a massive workforce or incredibly sustained activity over a very long time.
Which leads us to the big question. What was the function of this enormous network? What were they actually doing here?
The strong consensus, supported by this research and previous work, is that it was a large-scale agricultural system.
Okay, agriculture.
Yeah.
And how did that work in this particular environment with the Shaṭṭ Arab River nearby?
Well, the most likely mechanism was tidal irrigation. This area is connected to the al-ʿArab River, which in turn connects to the Gulf. The rising tide pushes fresh water upstream into the river estuary. This rise in water level could be harnessed to fill the canals that ran through this landscape, allowing for irrigation of the fields in between the ridges.
Ingenious, but also sounds like it requires constant management.
Exactly. It sounds like it would take a lot of work building the system, but then what were the ridges for? Why pile up all that earth?
Yeah, why the ridges?
There are a couple of main hypotheses, likely not mutually exclusive. They could be products of clearing and preparing new land for cultivation initially, but perhaps more importantly, the evidence suggests they likely represent the long-term maintenance of the system.
Maintenance? How so?
Tidal irrigation brings not just water, but also sediment and, crucially in this environment, salt. The ridges could have been built from clearing salt-affected soil or sediment deposited in the canals to prevent them from blocking.
So they're essentially massive piles of cleared-out material, like the ongoing waste product of keeping the system running.
That seems highly likely. Nelson's earlier work in the 1960s found that the ridge sediments were about twice as saline as the flat areas between them, strongly supporting the idea that material high in salt was being cleared and deposited there. Even 20th century reports and discussions with local farmers who still cultivate small areas between the ridges today highlight the ongoing need for maintenance, specifically clearing sediment.
Ah, okay. So it's not a system you build and then just leave. It requires continuous effort.
Precisely.
And it's not just unique to this region either, right? Comparable tidal irrigation systems exist elsewhere that also require significant labor.
That's true. You see comparable techniques in traditional West African rice cultivation dating back to around 1000 AD, and the Navazo system in coastal Spain, which has been practiced from at least the 16th century to the present. Both require significant labor investment in infrastructure and maintenance, much like the Iraqi system appears to have.
And critically, medieval texts, often overlooked in purely archaeological studies, offer fascinating clues about whether the system was still alive and how people used the tides.
They do. Medieval geographers provide context. Al-Muqaddaso in the 10th century described tidal mills at the mouths of canals near Basra, powered by the ebbing tide. Ali-Drasa in the 12th century noted how Basra's many canals were influenced by tides, with irrigation happening on the rising tide. And Abu al-Fidaz in the 14th century wrote about ships using the tidal influence to travel up the river and into the canals to reach Basra.
So these aren't just random observations. They paint a picture of an active tide-influenced landscape around Basra, even centuries later.
Exactly.
What about crops? Do we know what they were growing in between these massive ridges?
Not definitively across the entire system. Nelson suggested winter barley might have been the most likely crop in the flat areas. But medieval sources and current farming practices in the adjacent areas strongly emphasize date production.
Dates make sense for the region. They're relatively salt-tolerant.
They are, but the salinity levels Nelson measured in the flat areas, 15 DSM, are actually quite high. Modern studies show that level of salinity would significantly reduce date yields by over 50%.
Oh, wow. So even with dates, salt was a huge issue.
Yes, which highlights the challenge of salt accumulation and why that constant clearing and ridge building was probably necessary.
And medieval accounts mention them too, right? Especially in relation to the Zanj Rebellion.
Absolutely. Medieval sources repeatedly reference palm groves. Al-Abaria's account of the Zanj Rebellion mentions palm groves surrounding the salt flats, which provided cover for the rebels, and the dense trees made it difficult for Abbasid forces to pursue them. Traditional oasis cultivation often involved intercropping dates with other fruits, vegetables, rice, or barley, depending on spacing and shade, which might have been practiced here to mitigate some of those challenges.
So we have this incredible landscape, a huge agricultural system, likely relying on tidal irrigation and constant maintenance, all requiring immense human labor. This brings us to the human element. The people often link most strongly to these structures. The Zanj.
Yes, the structures are strongly linked in historical texts to forced labor, specifically by slaves known as the Zanj.
And Zanji is a medieval Arabic term for the East African Swahili coast. The dominant scholarly view has traditionally associated the Zanj slaves with that region.
But wait, I thought, isn't there debate about their origins, that maybe it wasn't exclusively East Africa?
There is. The sources mention alternative perspectives, Campbell's 2016 work, for example.
Right, based on genetic studies, broader slaving networks, and a comparative lack of specific evidence for a large East Africa to Iraq slave trade during this period, argues that most African slaves among the Zanj likely came from West and Western Central Africa. It's also noted that medieval authors used the term Zanj somewhat inconsistently, sometimes referring more generally to enslaved people of diverse origins, or even local peasants involved in revolts.
So the group was likely a mix of enslaved Africans and local people under terrible conditions.
It seems plausible, yes.
And these terrible conditions are tied to the famous Zanj Rebellion.
Precisely. A large-scale revolt against the Abbasid state in Iraq. It kicked off in 869 AD and lasted for over a decade, finally suppressed in 883 AD. There were actually earlier minor insurrections, but the 9th century one was clearly on a different scale.
And this study area lies right within the zone where the Zanj worked and where their headquarters, known as al-Mutara, are thought to have been located. So this area, these conditions, are essentially ground zero for the rebellion described in the histories.
That's the historical connection. The traditional historical link is that these earthworks were built by Zanj labor under brutal conditions, and the incredibly exploitative situation here was key to igniting that massive revolt, and crucially, that the revolt led to the system's collapse. But verifying that link and getting solid dates for the structures themselves has been a major challenge for archaeologists.
It has. These kinds of earthworks are notoriously difficult to date using traditional archaeological methods because they're just piles of dirt, essentially.
Exactly. And while medieval texts provide context, they aren't always definitive descriptions of the structures themselves or when exactly they were in use.
So how did this new research team finally get dates for something like this?
Well, they started with that detailed mapping from satellite imagery to understand the full extent of the system. Then they carefully selected sampling sites, 5 in total, 4 on ridge crests and 1 in a canal bed, spread across the system where preservation was good.
And they use a couple of different dating methods, including one that's really suitable for this kind of landscape.
Yes, both radiocarbon dating on shells they found in some ridges and optically stimulated luminescence, or OSL dating, on mineral grains from the sediments.
OSL is a technique we hear about more often now in archaeology, right? Why is it particularly useful here? How does it work?
It's really key for features involving sediment movement, like irrigation systems or earthworks built from moved soil. OSL dates the last time the mineral grains in the sediment were exposed to sunlight. Imagine the soil as like a tiny battery holding a charge from sunlight. When the soil is moved, say to build a ridge and then buried again, that battery starts charging up again from background radiation. OSL measures that accumulated charge to tell you how long it's been since it was last exposed to light.
It effectively resets the clock when the dirt was moved.
Oh,
Clever.
exactly.
And the sampling details. They took samples from different depths.
Yes, they excavated small trenches at the sites. They described the stratigraphy, which was mostly uniform silty clay in the ridges. And they took multiple samples from different depths at some sites, which is important because it helps them understand if the sediment was deposited all at once or accumulated over time.
All right, let's get to the results. What did the dating tell us? Starting with the radiocarbon dates from the shells.
The radiocarbon dates on the shells came back significantly earlier than expected for the medieval period we're discussing. Site 2 shells dated to AD 558-215 and Site 4 shells to AD 326-433.
Okay, so that sounds quite early. Does that mean the ridges were built by the Romans or Sassanids?
No, and it's crucial to understand why. These shell dates are not considered reliable age estimates for the structures themselves. They're likely older than the sediment they were found in. Shells could have been mixed in during construction from older layers, or there could be something called a reservoir effect, influencing the dates in this aquatic environment.
Okay.
The researchers treat them only as a terminus post quem, meaning the sediment accumulation happened after these shells were deposited. They give us a very early boundary, but not the actual construction date.
So the shells give us a hint of very early activity, but not the date of the ridges themselves. The real meat is in the OSL dates then, the ones that date when the dirt was piled up.
Exactly. The OSL results are the crucial piece here for dating the actual construction and accumulation of the ridges.
Okay, let's look at the canal bed first. Site 3, what did that show?
The deepest layers dated slightly earlier than the ridges, broadly spanning the late 8th to mid-11th century AD. But an upper layer dated much, much later, to the mid-15th century. There was a clay layer in between, which they suggest might represent a period of lower sedimentation, possibly corresponding with active canal cleaning during the time the adjacent ridge was being accumulated.
That hints at complex use over time. Okay, and the ridge crests. That's where the majority of the samples came from, and the most surprising results are found.
Precisely. All 4 ridge crests, sampled sites 1, 2, 4, and 5, returned OSL dates falling within the period between the late 9th and mid-13th century AD.
Wait, the Zanj Rebellion was suppressed in 883 AD, and the ridges date to between the late 9th and mid-13th century AD. That means they were being built after the rebellion ended.
Precisely. What's fascinating here is that these OSL dates provide the first material evidence for the chronology of the ridge's creation and use, and the results place this accumulation firmly within and after the traditional period associated with the Zanj Rebellion. The earliest OSL date from a ridge sample, 963 Ananshi 80 AD, confirms that at least some of these ridges were actively accumulating sediment, likely from maintenance or clearing, in the century following the end of the revolt.
Wow. And you mentioned samples from different depths in a single ridge. What did that show about how quickly they built up? Were they built in one go or constantly being added to?
At sites like Site 2, samples from different depths had overlapping date ranges. While the uncertainties mean it's hard to pinpoint exact years, it suggests that the sediment accumulation could have happened relatively quickly. Possibly over a few years, or maybe up to almost a century between the late 11th and early 13th centuries for that specific ridge.
So that supports the maintenance idea.
This strongly supports the idea of ongoing intermittent accumulation from clearing sediments rather than a single phase of building. It was maintenance, not just initial construction.
Here's where it gets really interesting. This completely challenges that traditional historical narrative we started with, the one that said the Zanj Rebellion killed the system.
Absolutely. The traditional view, based heavily on textual accounts focusing on the immediate aftermath of the brutal suppression of the revolt, is that the Zanj Rebellion marked a major turning point. leading to significant economic decline and the abandonment of this massive agricultural system built on the backs of slaves.
But the OSL dates directly contradict that for this specific area.
They demonstrate that large-scale cultivation and the associated work, the constant back-breaking accumulation of these massive ridges from clearing sediment, continued in this area for several centuries after the rebellion, at least up to the mid-13th century.
This suggests the economic impact of the Zanj Rebellion, while undoubtedly significant and horrific in human terms, was not as decisive or as immediately devastating to agricultural activity in this specific area as previously argued.
Right. The system, and perhaps the labor force, showed a surprising resilience or continuity.
And this even lines up with some medieval travelers' accounts from after the rebellion, which didn't describe total desolation, right?
It does. Noor Khusraw visited in 1051 AD, centuries after the revolt ended. He described Basra as smaller than it once was, but still wealthy and populous with strong walls. Ibn Battuta in the 1320s also noted its contemporary wealth.
And texts still mention canals and irrigation.
Exactly. Textual sources from this post-rebellion period still document canals, mills, and the practice of tidal irrigation in the hinterland around the city. It wouldn't make sense for those accounts to exist if the entire agricultural base had collapsed and been abandoned right after 883 AD.
This raises an important question. If this labor-intensive system was still in use for centuries after the Zanj Rebellion, and the Zanj were key to the traditional narrative of its collapse, who was providing the labor?
That's a crucial point. While the pattern and scale of slave use in this specific region might have changed after the revolt, some scholars argue it didn't simply stop entirely across the entire Abbasid Caliphate or even the region. For instance, Noor Khusraw, writing in 1050 AD, mentions seeing large numbers of African slaves working in fields and gardens in nearby eastern Arabia.
So the labor source might have changed, but didn't disappear entirely.
It's plausible that sufficient labor, whether enslaved people from different origins or other subjugated populations, remained available in the region for cultivation and the ongoing intensive maintenance needed to keep the ridge system functional.
Okay. The system didn't immediately die after the Zanj revolt then, that's the big surprise. But it did eventually fall out of use. Our sources suggest it was largely abandoned by the early 17th century, based on accounts like Pedro Teixeira's. So if the Zanj Rebellion wasn't the end, what might have caused its decline after the period of continued use, say from the mid-13th century onwards?
The study points to several potential factors for decline that would have occurred later, after the mid-13th century, suggesting a combination of environmental, economic, and social pressures converging. Disruption from Mongol invasions in the mid-13th century is one possibility, certainly impacting Iraq.
And broader economic shifts could have played a role too.
Yes, definitely. A shift in broader economic focus away from Baghdad and the Gulf region towards places like Cairo and the Red Sea in the later medieval period could have reduced the market for agricultural produce from southern Iraq, making such a huge, labor-intensive system less economically viable.
Makes sense. What about the environment?
Climatic change is also mentioned as a potential long-term stressor. Regional climate records indicate a long-term aridification trend starting around 950 AD and continuing. Reduced rainfall, and thus lower river levels over centuries, could have made tidal irrigation less effective or led to gradually lower crop yields over time, slowly undermining the system.
A slow squeeze from the climate. And then a major devastating factor in the 14th century would have been the spread of plague.
Absolutely. The spread of plague in the 14th century caused estimated high mortality across the Middle East, around 42%. Such mass mortality would have severely impacted any labor-intensive system like this, both by reducing the available workforce and potentially shrinking the population relying on its produce.
You see reports of decline elsewhere too, right?
Yes. Reports note a sharp decline in rural settlement near Baghdad during this period, likely reflecting this devastation.
So it seems like a combination of pressures converging over time, rather than one single immediate cause like the Zanj Rebellion.
Likely. The shift of Basra city's location between the mid-14th and early 16th centuries, moving closer to the main river channel, and the significantly reduced cultivation area seen today compared to the ancient system might reflect these wider decline factors taking hold over centuries. However, the study is careful to emphasize that these are potential factors, and further evidence is needed to definitively determine the primary cause or causes of the system's eventual large-scale decline after the 13th century.
So let's bring this together. What's the major significance of this research? What's the big takeaway?
The main significance is providing the first absolute dating for the use of this massive system. It directly challenges the traditional historical narrative that saw the Zanj Rebellion as the immediate death knell for this agricultural landscape. It shows that a large area remained under cultivation, with the ridges actively accumulating from ongoing maintenance for several centuries after the revolt into the 13th century.
That changes our understanding of that whole post-rebellion period in southern Iraq.
It really does.
And it's an important piece of landscape heritage, isn't it? A physical record of immense human effort.
Yes, absolutely. Jaafar Jotheri, one of the researchers, emphasized its importance for documented history and called for the protection of these structures. It represents a significant, large-scale human modification of the landscape that's been sitting there, waiting for us to understand its full story.
But as with any research, there are limitations, right?
Mm-hmm.
This isn't the absolute final word on the whole system.
For sure. The study notes that they sampled only 4 ridges out of over 7,000 identified.
Only 4. Wow.
And the sampled sites were also relatively close to the site of the medieval city of Basra, where economic activity might have persisted longer than in areas further afield. So while the findings are significant, they are based on a limited sample size of a vast area.
Only 4 out of over 7,000. What does that imply about what we still don't know? What future research is needed?
It implies there's a lot more to explore. To understand if cultivation continued everywhere equally across the whole 800 square kilometers, more dating is definitely needed across wider areas. For example, on the east bank of the Shaṭṭ al-ʿArab or further upriver, where tidal influence might have been different. More work is also needed to understand the specific agricultural practices in more detail, beyond the general tidal irrigation mechanism, and to pinpoint the exact factors that led to the eventual decline after the 13th century.
The story isn't over. This is a major new chapter.
Definitely.
So what does this all mean for you? We started by looking at these immense ancient earthworks in southern Iraq, long linked to the Zanj Rebellion, and thought to have fallen into disuse because of it.
But the new evidence, using techniques like OSL dating, tells a more nuanced story. It seems the Zanj Rebellion, as pivotal and devastating as it was in human terms, didn't immediately kill off this agricultural system. Activity and the astonishing accumulation of these ridges through maintenance continued for centuries afterward, challenging our understanding of that historical period and the resilience of human effort and labor arrangements in the region.
These ridges aren't just dirt and sediment. They're material proof of a massive, sustained effort tied into the natural rhythm of the river's tides and the complex, often harsh, history of human labor in the region. They also serve as a powerful reminder that history isn't always a straight line of simple cause and effect. The impacts of major events can be complex, long unfolding, and often surprising us when new material evidence comes to light.
And remember, this is just 4 ridges out of over 7,000. Think of what else is waiting to be discovered in that landscape.
For you thinking about this, what stands out? How does new archaeological evidence like this change how we look at major historical turning points? It makes you wonder how many other traditional historical narratives, even well-established ones, might be ready for a deep dive and a reevaluation based on what's literally hidden beneath the surface.